So this topic is related to the mass spectrometer and ionization energy. So in this question they mention a p block element which is in period 3 react to form an ionic compound. So what could be the electronic configuration? So when we check the periodic table, the period 3 element, because in the first period we have hydrogen and helium, in the second period we have lithium, beryllium, boron is there, carbon is there, nitrogen is there, oxygen is there, fluorine and neon. And in the third period, what we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and then argon. So sodium is having 11 protons, atomic number 11, magnesium 12, aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. When we write the electronic configuration, it will be 1s2, 2s2, 2p6, and 3s1. So it cannot be magnesium or and sodium or magnesium. Why it cannot be sodium or magnesium? Because when you check the periodic table, they are S block elements. So answer can be aluminum, silicon, phosphorus, sulfur, chlorine. And when they react with each other, because when we write the electronic configuration for aluminum, if it react, like aluminum will be 1s2, 2s2, 2p6, 3s2, 3p1. So when aluminum will react, it will lose all of its valence electron. So electronic configuration of aluminum will be 1s2, 2s2, 2p6. So if it loses, because to form an ionic compound, it should lose electron. So it cannot be aluminum or it cannot be 1s2, 2s2, 2p6 because there is no option here. Then it can be for silicon, from silicon to chlorine. So when these non-metal react in ionic compound, they tend to gain electron. Like if phosphorus, if we take example of phosphorus, which is 15, it is having 15. To make it 18, it will take 3 electrons. So when it will take 3 electron, so the electron, or if it was sulfur, which is 16, it will take 2 electron. If it is chlorine, which is 17, it will take 1 electron. So total number of electrons will be 18. And what is the configuration for 18 electron? So for all of them, 1s2, 2s2, 2p6, 3s2, and 3p6. That's why B is the right answer. Is it clear why B is the correct answer? Because we need a configuration of the ion. We don't need an atom. They ask for the configuration of the ion which form an ionic compound. In question 13, period 2 element with the highest melting temperature. So period 2 element, what are the element in period 2? As we already discussed, like we have lithium, then beryllium, then boron, then carbon, then nitrogen, oxygen, and then fluorine and neon. So first 3 elements, they will be metallic, then carbon will be a macromolecule. Aluminium belongs to group 3, boron belongs to group 3, carbon belongs to group 4. But when we check the period, second period, so aluminum does not belong to second period, element belongs to period 3. Where also silicon also belongs to period 3. Boron belongs to period 2. Carbon also belongs to period 2. But we need the highest one. Because carbon, it will have a macromolecular structure, giant structure in which all the covalent bonds are present between the atoms, which result in a stronger attraction, leads to high melting point. Then this question is about the element sulfur, which is having 16 electrons. Complete a diagram to show the electronic configuration of a sulfur in a ground state. Include the label for each subshell. So we have to label each subshell. So remember this table when you're completing electronic configuration. That is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, and then 7s. So we complete each arrow. Like first it will be 1s, then 2s, then 2p, 3s, 3p, 4s, then 3d, 4p, 5s, then 5d, 4d, 5p, 6s, and then 4f, 5d, 6p, and 7s. So for 16 electron sulfur atom, they are mentioning. So 16 electrons, how they are arranged, it will be 1s2, 2s2, 2p6, 3s2. So we arrange till 12, and then 3p4 will be there. So this is 1s. Then after that 2s, it will have 2 electrons clockwise and anti-clockwise. Then 2p subshell. 2p subshell is divided into 3 orbitals, 2px, 2py, 2pz. Because there are 6 electrons, so 1, 2, 3, 4, 5, 6. And then it is 3s, which is 1 and 2. And then we have 3p, which is having 4 electrons, so 1, 2, 3, and 4. So there are 2 unpaired electrons present in the 3p subshell. Is it clear this one? That we completed the electron in a box model. Then write equation for the first ionization energy of sulfur. First ionization when electron is removed from neutral gaseous atom. So this will be always, it will form a positive ion, and this is called a first ionization energy. One mark is for the correct symbols, and the second mark is for correct state symbol. Explain why the first ionization energy of sulfur is less than the first ionization energy of phosphorus and chlorine. So the best thing, if you want to compare, you will always write an electronic configuration. Phosphorus is having 15 electrons, sulfur is having 16 electrons, and chlorine is having 17 electrons. So 17 electron, 15 electrons and 15 protons, 16 electrons, 16 proton, and 17 electrons, 17 proton. So when we write for sulfur, phosphorus, 1s2, 2s2, 2p6, 3s2, 3p3. So in the p subshell, when they occupy the orbital, they will occupy singly in phosphorus. So there is less repulsion between the electron. But in case of sulfur, what happened? When we write the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p4. So the 3p orbital, the p orbital and 3 subshell, the 3p subshell. So there are 4 electrons, and how these 4 electrons are arranged? 1, that is 1, 2, 3, and then 4. So there is a pair of electron, and this pair will have more repulsion. So it will be easy to remove electron. That's why this sulfur will have a lower ionization energy compared to that of phosphorus. And when we write the electronic configuration for chlorine, which is having 17 electron, which is 1s2, 2s2, 2p6, 3s2, 3p5. So when we take the p orbital, so 5 electron in the p, because I'm not, this is for the last shell only, not for the full electron in a box model. So it will have 5 electrons. So when how the 5 electrons are arranged: one, two, three, 4, and 5. So there are two pairs. So two pairs are there. They will have more repulsion compared to that of sulfur. But still, compared to sulfur, chlorine is having the higher ionization energy. So what is the reason? Basically, sulfur is having 16 proton, but chlorine is having 17 proton. So it will have a greater nuclear charge. That's why it will have a greater attraction toward the nucleus. So it will be difficult to remove electron from chlorine even though there are two pairs. So is it clear why phosphorus is having higher than sulfur? This phosphorus is having higher than sulfur, that is due to the pair. And why chlorine is having higher than sulfur, that is due to more protons or stronger attraction. Is it clear this part? So even though there are two pairs, but because these two pairs are, they will have repulsion, but compared to that repulsion, attraction is much higher because there is a greater nuclear charge or more proton. That's why chlorine will have higher ionization energy than sulfur. Yeah, the more nuclear charge means more ionization, but the two of the groups does not follow that. Like even when you see, when you compare, phosphorus is having 15 protons, sulfur is having 16 proton. So sulfur is having more charge, but more charge is there, but there is a pair of electron, their repulsion is higher. That's why it will become easy to remove. So sulfur does not follow the same trend. And when we compare sulfur with chlorine, chlorine is having greater nuclear charge than sulfur. So repulsion is weaker as compared to attraction. That's why it will have a higher ionization energy. So greater nuclear charge, greater ionization, but not in case of sulfur because it does not follow that trend. And this question is related to the average mass of the isotope. We already discussed this. So in this question, the first ionization energies in kilojoule per mole for four elements with a consecutive atomic number are shown. So the consecutive atomic number, basically what is the idea? Like when you have group 1, group 2, group 3, group 4, 5, 6, 7, and 8. So when we move, so group 1 will be there, group 2, then group 3 will be a bit less. Why? Because the subshell changes. Then group 4, 5 will be there, and then group 6. Why group 6 is smaller? because there is a pair of electron, then group 7, and then the peak will be there for group 8. So they mentioned these are successive ionization, and these are four elements successive. So A is there, B, then C, and then D. So we have to identify first from this result from which group they belongs to. So first what is happening? A and B ionization energy increase, then C decreases, and it's and D it increases. But what happened? You can see that for C there's a big decrease from C to D. So what it shows? It shows the period changes. Like what does it mean? It means that A and B, A belongs to group 7, B belongs to group 8, then C belongs to group 1, and D belongs to group 2. Why? Because first it was increasing ionization energy across the period, it continued to increase. So, but what is happening? A is increasing, then B, and then from C it decreases, and it's a two big decrease. So, what it shows? It shows the period change. So, if the period changes, which element could be an inert gas? Inert gas means group 8. So, what could be the answer for group 8? A, B, C, or D? Group 8 will have the highest ionization energy because their shells are complete. So, that will be B. Which element could be X in a covalent compound with a formula HX? So, basically, HX means H is positive or sharing one electron only, forming a covalent bond. As hydrogen share one, that X is also sharing one. So which group sharing one electron? That is group 7. So which one is group 7? A is group 7. And which element could be Y in ionic compound with a formula? So means it should be a metal which is losing 2 electron, or group 2. So which one is group 2? D is group 2. Is it clear this example? In this question, the graph shows a second ionization. So first ionization is already done. This is a second ionization graph. So which element could be lithium? So how you identify, look, when we write the electronic configuration for lithium, which is 3, so it will be 1s2, 2s1. When one electron is removed from lithium, the first ionization, so when one electron is removed, what will be the electronic configuration? It will be 1s2. And 1s2 means it is similar to like same as helium. And helium will have the highest, helium is having the highest ionization energy because the shell is closer and it is having a greater charge compared to that of hydrogen. So which one is the highest value? A, B, C, D. So B is having the highest peak. That's why B will be the right answer. Because the graph is for second ionization. So when second ionization of helium is there, it matches with the configuration of when second ionization of lithium is there, it matches with the electronic structure of helium. That's why it will have the highest ionization energy. So B will be the right answer. Is it clear this one? Question 18. The first five ionization energies of aluminium are shown. The orbital from which the first five electrons removed during. So first we have to write the electronic configuration of aluminium, which is 13. So it will be 1s2, 2s2, 2p6, 3s2, 3p1. So when we remove the electron is always removed from the last shell. So when we remove electron, first electron will be removed from 3p. Then second electron removed from 3s. Then another electron also removed from 3s. Then electron removed from 2p. Then another electron also removed from 2p. So this will be the order of removal of electron. The last shell first. So 3p, 3s, 3s, 2p, 2p. So D will be the right answer. In question 20, going across the periodic table from sodium to aluminium, so the size decrease, the melting point increases because greater charge is there or greater number of electrons within the structure. So what happens? The melting point increases, that's true. The radius does not increase. The radius of metal ion does not increase, it decreases. Bonding of element changes. No, it remains metallic, it does not changes from metallic to covalent. If it was from sodium to chlorine, then we say it will change from metallic to covalent. But because they are asking only from sodium to aluminium, so it will remain same as metallic bond. The graph below shows the successive ionization energy of element X plotted against the number of electrons removed. From the graph, it is possible to deduce a group. So what is the group of this? As you can see, there is a difference between the first and the second, but then only two electrons are removed from this. So what it shows that this change is due to change in subshell. And then there's a big jump and electrons are there, and this change is due to change in the shell. So how many electrons are there in the last shell? So we can identify there are three electrons are there in the last shell. So if three electron in the last shell, which group this element belongs to? It belongs to group 3. And from the graph, it is possible to deduce the most stable ion. If element belongs to group 3, it tend to lose 3 electrons. So what will be the charge? It will be 3 plus. So A will be the right answer. Is it clear? So using the logarithm of ionization and electron remove, we can also work out the group of that element. Then define the term relative atomic mass. It is average mass of an atom or average mass of an atom which is compared with carbon 12. That we call as a relative atomic mass. Then the mass spectrometer questions we are skipping as we already completed. Which change is atomization? The term atomization means when we produce 1 mole of atom, in the gaseous state. So in which one we are producing 1 mole? either A or D. But you can see here we are producing 1 mole of molecule in a gaseous state, but we should produce 1 mole of atom in a gaseous state. So D is the right answer. Then question 24, which group element belongs to? These are the successive ionization. So 789, 1500, 3000, 4000, and suddenly very big jump from 4000 to 16,000. So this is a big jump. When it's a big jump, it means the electrons which were removed initially were from the last shell, or it shows the shell changes. So how many electrons are removed before this big jump? So 4 electrons are removed. It means this element belongs to group 4. Is it clear? So aluminum with a charge +4, the fourth electron is lost. So we have to again work out the electronic configuration. It will be 1s2. Aluminum atom is 13 electrons. So 1s2, 2s2, 2p6, 3s2, 3p1. So first electron is removed from 3p, then from 3s, then from 3s, and then from 2p. So we remove from 2p subshell. So C will be the right answer. Hydrogen is having 3 isotopes in terms of subatomic particle. How they are similar? They will have same protons. And how they are different? They will have different neutrons in the nucleus. When nitrogen atom collide with high energy neutron, one atom of tritium and another element is formed. So how we can work out element? Because the overall equation should be balanced. So here on the left hand side, total number 7. So on the right hand side, it should be 7. So 1 is there. So it should be 6. And the total mass is 14 plus 1, 15. So 3 are there. So this should be 12. An element with atomic number 6, that is carbon. So it will produce carbon atom. That's about the relative atomic masses, mass spectrometer. The electronic energy level for hydrogen is shown. Use the electronic suggests why this is the first part was mark on an energy level diagram. Transition represent the ionization. Ionization means when electron is removed from the atom. So infinity means, the sign infinity means it is outside the atom. And in hydrogen we have electron in the first shell. So when electron from first shell move outside the atom, we call that as ionization. So we have to draw this arrow. Then in some versions of the periodic table, hydrogen is placed in same group as sodium. Give the electronic configuration for both hydrogen. So hydrogen it is 1s1, for sodium it is 1s2, 2s2, 2p6 and 3s1. Which element in the has the highest first ionization, and justify your answer. So which element is having the highest ionization in the periodic table? That is helium. And why helium is having the highest ionization? Because electronic configuration is 1s2, or it is having 2 protons, 2 neutrons, and first shell is complete. So reason when we write, we'll mention it is having a complete shell. And due to this complete shell, there is more attraction, and electrons are closer to the nucleus, so they will have more attraction. That's why it is having the highest. So the mark distribution, why 3 marks? 1 mark is for mentioning helium, 1 mark is for mentioning no shielding effect, because you can see when we are removing the electron, we are removing the electron from the first shell, and there is no inner shell electron, so there is no shielding effect or very small shielding effect, you can say. And the second thing, electrons are closer to nucleus. Then the number of unpaired electron in nitrogen atom in a ground state. So nitrogen atomic number is 7, electronic configuration 1s2, 2s2, 2p3. So first, when electron in a box model, when we represent first shell, there's a pair of electron, then pair, and then singly. So how many unpaired electrons are there? You can see 1, 2, and 3. That's why D will be the right answer. Then 4 sequences of ionization energies are given. The sequence which give the first ionization energy of element going down the group. So when we go down the group, the size increases, so ionization energy will, as the size increases down the group, the ionization energy will decrease. So which pair is representing the decreasing in ionization? Continuous decrease in ionization. When you check option B, it is a continuous decrease, so that's why B will be the right answer. Which sequence shows the first 5 ionization energy of calcium? So for calcium, when we write the electronic configuration, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So when we remove electron, the first two should be closer, and then there should be a big jump between the second and the third ionization. So there should be a big jump between the second and third ionization. So 590, 1100, and when you compare this jump, it's about 5000. So it's a big jump moving from the second to third ionization. So calcium A is the right answer. And the sequence of first ionization in which the atomic number increases by 1 starting from element group 6. So group 6, then group 7, group 8. So first it should increase, and then we move on to group 1 and 2 because of period change, so it should decrease. So first 3 should increase, and then there should be a decrease in the value. So first 3 values, when we check, it increases 1, 2, and 3, and then there's a decrease, sudden decrease, and then again it will start to increase. So that's why C is the right answer. Is it clear, this one? Then we have to write the electronic configuration for silicon. So it will, silicon is having 14 electrons. So, and for this isotope, which is having mass 29, proton will be 14, this will be 14, and this will be 15. So 1s2, 2s2, 2p6, 3s2, 3p3. So we arrange 15. Explain in terms of structure and bonding, why silicon is having higher than phosphorus? So silicon, it's a group 4, so it will be a macromolecule. Phosphorus will be a simple covalent structure. Stronger bonds, more energy is needed. Whereas in silicon, in phosphorus, the bond will be weaker. So small amount of energy can break these intermolecular forces. And suggest why atomic radius decrease as we move across the period. So as we move across the period, the nuclear charge increases. So as the nuclear charge increases, it's of 2 marks. So distribution of the marks, you will mention when we move across the period, the nuclear charge is increasing. So a stronger attraction will be there between the nucleus and the last shell electron for the same shielding effect. So 1 mark is for, because all in the period they all have the same shielding effect, but the charge is increasing. That's why the ionization energy increases. Then we have to draw a dot and cross diagram of silicon tetrachloride. So silicon belongs to group 4, so it will share 4 electrons. Chlorine belongs to group 7, so it will share 1 electron. And then the unshared electron on silicon, no unshared electron, as it belongs to group 4, so it share all 4, where chlorine share 1 and unshared will be 6 electrons. So this was the assignment related to topic mass spectrometer and ionization. Any question related to the class today? So I'll end the session and share this with you.